limits and derivatives. Now we are going to learn about limit. What is a limit of a function? So we know the word limit, isn't it? You know the meaning of the word limit. So it means a boundary. A limit is the boundary. So for the function, what is the limit value? So here it is a definition. F be a real valued function of x. Let L and A be two fixed numbers if f of x approaches the value L as x approaches to A. When x approaches to A, when x tends to A, f of x approaches the value L. x க்கு a வரும்போது f of x ஓட value L ஆகுது. Then we say that L is the limit of the function f of x as x tends to a, and we can write it as limit x tends to a, f of x is equal to 1. Limit x tends to a, f of x is equal to L. So when x tends to a, when x approaches a, f of x is equal to L. x க்கு a கொடுக்கும்போது f of x is equal to L. That's not the exact value, that is the limit. Okay. So here left hand limit or right hand limit. So on both the sides we have the limits, we have the boundaries. So L of f of x, x equal to a is equal to limit x tends to a minus f of x. x tends to a minus f of x is the left hand limit at x is equal to a. R of f of x, that is limit x tends to a plus f of x, is known as the right hand limit of f of x. So left hand limit, right hand limit we can calculate for the function. So if both left hand limit and right hand limit exist, then we can tell that limit is exist. So limit f of x exists if and only if L of f of x is equal to R of f of x when x is equal to a. If left hand limit and right hand limit are equal, then we can tell that the limit exists. Limit exists. Okay. So the left hand limit and right hand limit are shortly written as L of f of a and R of f of a. How to calculate the left hand limit? First we have to write limit x tends to a minus f of x. That's the first step. Limit x tends to a minus f of x. Then we have to put x is equal to a minus h. Obtain limit x tends to 0 f of a minus h. And now the value obtained is the left hand limit. So first write the limit as limit x tends to a minus f of x, and then put x is equal to a minus h when h is greater than 0. Now we have to obtain, we have to evaluate the value of that limit. Okay, so this is known as the left hand limit. Similarly for right hand limit, you have to write f tends to a plus f of x, and you have to put x is equal to a plus h, and then you have to obtain the value of limit h tends to 0 f of a plus h, because instead of x we have substituted a plus h. Now the value obtained in this step is known as the right hand limit of the function. Some results of limits. So if limit x tends to a f of x and limit x tends to a g of x exist, then limit x tends to a f plus or minus g of x is equal to limit x tends to a f of x plus or minus limit x tends to a g of x. So if plus comes here, then it will be plus. If minus comes here, it will be minus here. Okay, and product also, f g of x is equal to, you can split the limit as the product of two functions. and division also. The limit x tends to a f by g of x is equal to, the limit is common for both the numerator and denominator. Limit x tends to a f of x divided by limit x tends to a g of x. Whenever limit x tends to a g of x is not equal to 0. If you multiply the function with the constant k, then the function you can multiply it with k. The function will be multiplied with k also, where k is a constant. And indeterminate forms, it is very important. So, f of x and g of x are two functions. So, if it takes 0 by 0 form, then it is meaningless. So, we will tell it is in indeterminate form. These are the indeterminate forms. So, the indeterminate forms are 0 by 0, infinity by infinity, 0 into 0, 0 into infinity. These are all the indeterminate forms. So, standard limits, some standard limits. The first one, limit x power n minus a power n divided by x minus a, that is equal to n into a power n minus 1. If the limit is of this form, then this is n into a power n minus 1, the value. Okay. So, limit theta tends to 0, sin theta by theta, that is equal to 1. The value of this sin theta by theta is equal to 1. Similarly, limit theta tends to 0, tan theta by theta is also equal to 1. So, limit a power x minus 1 by x, that is equal to log a. Limit log 1 plus x by x is equal to 1. If x tends to 0, log 1 plus x by x is equal to 1. Similarly, fifth one, limit x tends to 0, 1 plus x the whole power 1 by x, that is equal to e. Sixth one, limit x tends to infinity, 1 plus 1 by x the whole power x is equal to e. Seventh one, limit x tends to 0, e power x minus 1 divided by x is equal to 1. So, if you are having the limits, the functions in this form, you can apply the value, you can apply the answers directly, but the limit also should be same. Okay. If I have to apply n a power n minus 1, then the limit also should be x tends to a, x power n minus a power n divided by x minus a. First one, evaluate limit x tends to 2 x cube plus 2 divided by x plus 1. So, here instead of x we have to substitute 2, because x tends to 2, we have to find the value of this function. So, that is equal to x cube. So, 2 cube plus 2 divided by 2 plus 1. 2 cube is 2 into 2 into 2, it is 8. So, 8 plus 2 divided by 3, that is equal to 10 by 3, that is the value of this one. Second one, limit x tends to infinity, 2x plus 5 divided by x square plus 3x plus 9. Infinity, it is infinite value, we couldn't substitute it into x directly. Okay. So, when and all infinity is coming, we used to substitute like this, as when x tends to 0, 1 by x tends to infinity. When x tends to 0, 1 by x tends to infinity, that is 1 by 0 is always infinity, isn't it? Anything divided by 0 is infinity. So, when x tends to 0, 1 by x is infinity. So, always we should try to bring x in the denominator. So, we have to take x out from the first expression, that is 2x plus 5. If I take x outside, then it will become 2 plus 5 by x, isn't it? While taking x outside, we have to divide the terms by x. So, x into 2 plus 5 by x. Similarly, in the denominator I am going to take x square. If I take x square outside, here the first term will become 1 plus the second term will become 3 by x. The third term will become 9 by x square. So, x square into 1 plus 3 by x plus 9 by x square. So, now the limit is there, x tends to infinity. The function f of x is transformed like this. We have changed it like this. Okay. So, limit x tends to 0 to x plus 5 divided by x square plus 3x plus 9 is equal to limit x tends to infinity x into 2 plus 5 by x by x square plus x square into 1 plus 3 by x plus 9 by x square. Now, I am going to apply the limit, that is equal to 1 by x tends to infinity if x tends to 0. Okay. So, now I can cancel 1x. So, it is 1 by x, limit x tends to infinity 1 by x into 2 plus 5 by x divided by 1 plus 3 by x plus 9 by x square. Now, similarly, when x tends to infinity, 1 by x tends to 0. These two are very important results. When x tends to infinity, 1 by x tends to 0. When x tends to 0, 1 by x tends to infinity. Here we have 1 by x. So, when x tends to infinity, 1 by x tends to 0. So, here while applying the limit, this 1 by x tends to 0 into 2 plus 5 by x. So, it is also 0 divided by 1 plus 3 by x, that term will become 0 plus 9 by x square, it also will become 0. So, here 2 by 1, but while multiplying it with 0, the whole expression is equal to 0. So, while I applying the limit x tends to infinity, f of x is equal to 0. Now, third one, limit x tends to infinity sigma n divided by n square. What is sigma n? Summation n. We know summation n is equal to 1 plus 2 plus 3 etc. up to n. What is the formula for this? N into n plus 1 divided by 2, isn't it? So, here limit x tends to infinity, sigma n by n square is equal to n into n plus 1 by 2 divided by n square, that is equal to n into n plus 1 by 2n square. So, n and n will get cancelled. Now, limit x tends to infinity. So, here limit tends to infinity. So, now we are going to take n outside. So, n into 1 plus 1 by n divided by 2n. 1 by 2 into 1 plus 1 by n. Here n and n will get cancelled. Now, you have to write this limit x tends to infinity. Okay. So, now we are going to substitute the value, that is limit x tends to infinity. So, while applying the limit x tends to infinity, this will become 1 by 2 into 1 plus 0, because when x tends to infinity, 1 by n tends to 0. So, 1 by 2 into 1 plus 0, that is equal to 1 by 2. So, limit x tends to infinity, sigma n by n square is equal to 1 by 2. Evaluate. Limit x tends to 0, square root of 1 plus x minus square root of 1 minus x divided by 5x. So, here I am going to, if I substitute 0 directly, then the numerator will become 0, isn't it? So, I am going to multiply the numerator and denominator by its conjugate. by the conjugate of this term, this numerator. Okay, so square root of 1 plus x plus square root of 1 minus x is the conjugate for this. So I am multiplying the numerator and denominator by its conjugate. Here a minus b into a plus b, that is a square minus b square, divided by 5x into square root of 1 plus x plus square root of 1 minus x. That is square root of 1 plus x the whole square, that will become 1 plus x. Square root of 1 minus x the whole square, that will become 1 minus x, divided by 5x into square root of 1 plus x plus square root of 1 minus x. Limit x tends to 0. This limit should come till you apply the value. Okay, after applying the value, no need to write limit x tends to 0. Okay, so here in the numerator, 1 minus 1 will get cancelled. 1 and minus 1 will get cancelled. X plus x, that will become 2x. 2x divided by 5x into square root of 1 plus x plus square root of 1 minus x. Now x and x will get cancelled. So it will become 2 divided by 5 square root of 1 plus 0 plus square root of 1 minus 0. Why 0 is coming here? Here we are applying the limit. So I didn't write it here. Limit x tends to 0. Inge eludala. Okay, so till this step we have it. Limit x tends to 0. Now it got cancelled and I am applying the limit, that is 2 divided by 5 into square root of 1 plus 0 plus square root of 1 minus 0. So it will become square root of 1 and this also will become square root of 1. What is square root of 1? That is equal to 1. So 2 divided by 5 into 1 plus 1. 1 plus 1 is 2. So 2 and 2 will get cancelled, or 2 divided by 10, and that is equal to 1 by 5. That's the value of this function. Fifth problem, limit x tends to a, x power 5 by 8 minus a power 5 by 8 divided by x power 2 by 3 minus a power 2 by 3. We have to find the value of this function. So, before applying the limit, I want to bring, if I apply limit directly, if x tends to a is given here, if I substitute a for x, then the numerator and denominator will get 0. It will be in indeterminate form. So, I want to bring this limit, this function using this function. I want to transform this function using the standard limit form. So, we are having a function, we are having a standard limit, that is limit x tends to a, x power n minus a power n divided by x minus a, that is equal to n a power n minus 1 if n belongs to q. So, here n for the power of x and power of a is same, is n, and we have the negative symbol in between. Similarly, here in the numerator as well as in the denominator, the power is same. Power of x and a is same in the numerator, that is a 5 by 8, and power of x and a is same in the denominator too, that is 2 by 3. So, to bring this function into this form, I am going to divide the numerator and denominator by x minus a. If I divide the numerator and denominator with the same value, the whole value, the value of the function doesn't change, isn't it? So, I am going to divide the numerator and denominator by x minus a. Okay, so now the numerator is in this form and the denominator is also in this form. Now we can apply. While applying the limit x tends to a, limit x tends to a, x power n minus a power n divided by x minus a is equal to n into a power n minus 1. So, that is equal to, now we are applying the limit, for the numerator it is n into a power n minus 1. What is n here? N is 5 by 8. 5 by 8, a power 5 by 8 minus 1, and it is for numerator. Now, for denominator, it is also x power n minus a power n divided by x minus a, and the limit is also same, x tends to a. So, the denominator will become 2 by 3 into a power 2 by 3 minus 1. Okay, now we can subtract it. That is 5 by 8 into, in the denominator we have 2 by 3, so we can multiply it with the reciprocal. So 3 by 2 into a power 5 by 8 minus 1. While taking a as LCM, 8 as LCM, we have 5 minus 8. Similarly, in the denominator, while taking 3 as LCM, it will become 2 minus 3. That is equal to 5 3s are 15. 15 divided by 16. 8 2s are 16. 15 divided by 16. That is a power 5 minus 8 evalama? Minus 3 by 8. Here a power minus 1 by 3. Okay. So now we can transform it. We can move this denominator to the numerator. That is equal to 15 by 16 into a power 1 by 3 minus 3 by 8. Now for the numerator we can take 24 as LCM. Isn't it? So 15 by 16 a power 24 as LCM. So here 8 minus, we have to multiply this with 3, isn't it? 8. So 3 3s are 9. That is equal to 15 by 16 a power minus 1 divided by 24 is the value. Limit x tends to 0, sin square 3x divided by x square. So we have to find the value of this function, this limit, while applying this limit. So here also we have a standard limit, that is limit theta tends to 0, sin theta divided by theta is equal to 1. We have to convert this function that it suits this. Okay, so sin theta by theta equal to 1. But here we have sin square 3x by x square. So I split this as limit x tends to 0, sin 3x by x into sin 3x by x. Sin square 3x, but sin 3x by x, sin 3x by x. But here the angle theta should be in the denominator. Here we have 3x, but in the denominator we have only x. Similarly, so here also 3x is there as a degree, sin 3x divided by x only we have. But in the denominator 3x should come. So for that I am going to multiply the numerator and denominator by 3. So 3 sin x. Similarly here also 3 sin x divided by 3x. Okay. Now for this expression I can apply this limit. So that is 3 into 3, 9. 9 limit x tends to 0, sin 3x by 3x into sin 3x by 3x. For this we have the limit x tends to 0. Here theta tends to 0. So while applying the limit sin 3x divided by 3x, that will become 1. 9 into 1 into, here also limit x tends to 0, sin 3x divided by 3x is equal to 1. So 9 into 1 into 1, that is equal to 9. That's the value of this. Second one, if limit x power 9 plus a power 9 divided by x minus a is equal to limit x tends to 3, x plus 6. Find the value of a. So here also this is similar to the standard limit. So we can apply the value directly. So we are going to apply this and then we will find the value of a. Okay. Limit x tends to a, x power 9 plus a power 9 divided by x minus a is equal to n a power n minus 1. What is our n here? 9. 9 a power 9 minus 1, that is equal to 9 a power 8. Here on the right hand side, limit x tends to 3, x plus 6. while applying the limit, we can apply 3 to x. So 3 plus 6, that is equal to 9. What we have to do now? We have to find the value of a. As it is given that these two limits are equal, we can equate these two. So 9a power 8 is equal to 9. So we can cancel 9 and 9, and that implies a power 8 is equal to 1. That implies a is equal to plus or minus 1. So plus 1 or minus 1 it may be, but while taking an even power it will be equal to 1. If limit x tends to 2, x power n minus 2 power n divided by x minus 2 is equal to 448, find the least positive integer n. So limit x tends to 2, x power n minus 2 power n divided by x minus 2 is equal to, while applying the general form of the standard limit, we get n a power n minus 1. Here we have a as 2. So 2 power n minus 1. We have to find the value of n, and it is given that this limit is equal to 448. So limit x tends to 2, x power n minus 2 power n divided by x minus 2 is equal to n into 2 power n minus 1, and that is equal to 448. Now we have to write 448 in the powers of 2. So while dividing 448 like this, let's check what powers of 2 it holds. So here we can write 448 as 7 into 1, 2, 3, 4, 5, 6, 2 power 6. Okay, that is n into 2 power n minus 1 is equal to 7 into 2 power 6. That implies 7 into 2 power, I can write 6 as 7 minus 1. That is n into 2 power n minus 1 is equal to 7 into 2 power 7 minus 1. That implies n is equal to what? 7. So n 7 is the least positive integer, and that's the answer. If f of x is equal to x power 7 minus 128 divided by x power 5 minus 32, then find limit x tends to 2 f of x. So we have to find the value of this function while applying limit x tends to 2. So I am going to write, to apply the standard limit form, I am going to I am going to write 128 in powers of 2. Similarly 32 also in powers of 2. So while dividing 128, we get 2 power 7. 128 is equal to 2 power 7. So f of x is equal to x power 7 minus 128 as 2 power 7 divided by x power 5 minus 32 as 32. While dividing 32 by 2, 32 is equal to 1, 2, 3, 4, 5 powers. Okay, 2 power 5. We can write 32 as 2 power 5. Now we can apply limit x tends to 2. So limit x tends to 2, our function x power 7 minus 2 power 7 divided by x power 5 minus 2 power 5. So to bring this in our standard form, I am dividing the numerator and denominator by x minus 2. So after dividing this, the numerator and denominator are of the form x power n minus a power n divided by x minus a. So here for the numerator, the value is n into a power n minus 1. Here n is 7. So 7 into a is 2. 7 into 2 power 7 minus 1. Similarly for the denominator, x, that is x power 5 minus 2 power 5. So n is 5 here. So 5 into 2 power 5 minus 1. Okay. Which standard limit function we are applying here? Limit x tends to a, x power n minus a power n divided by x minus a is equal to n into a power n minus 1. So 2 power 7 minus 1 and 5 power 5 into 2 power 5 minus 1. So 7 by 5 into 2 power 6 into 2 power 4. 2 power 4 in the denominator. So while bringing it to the numerator, it will become 2 power 6 minus 4. That is 2 square. 2 square is equal to 4. So 7 into 4, it is 28 divided by 5, and that's the answer. Sixth one, let f of x is equal to ax plus b divided by x plus 1 if limit x tends to 0, f of x equal to 2, and limit x tends to infinity, f of x is equal to 1, then show that f of minus 2 is equal to 0. So f of x is equal to ax plus b divided by x plus 1. First, it's given that limit x tends to 0, f of x is equal to 2. Limit x tends to 0, f of x is equal to 2. So limit x tends to 0, f of x equal to 2. Here we have to apply limit x tends to 0 for this function. So limit x tends to 0, ax plus b divided by x plus 1 is equal to 2. அதுவும் கொடுத்திருக்கு. So now while applying the limit, it will become a into 0 plus b divided by 0 plus 1. That is equal to 2. So a into 0, so this term will become 0. In the denominator, it is 1. So b is equal to 2. Now another one condition is given. Limit x tends to infinity, f of x is equal to 1. Limit x tends to infinity, f of x is equal to 1. So limit x tends to infinity, what is our f of x? Ax plus b divided by x plus 1 is equal to 1. So as it is x tends to infinity, we couldn't apply it directly. So limit x tends to infinity, I have to take x commonly into a plus b by x. X common edutha a plus b by x. Similarly, in the denominator, x into 1 plus 1 by x, that is equal to 1. X and x will get cancelled while applying limit. So b by infinity varum. Okay. So when x tends to infinity, 1 by x tends to 0. When x tends to infinity, 1 by x tends to 0. So while applying the limit, here a plus 0, b by x will become 0. In the denominator, 1 plus 0, that is equal to 1. That implies a by 1, that is a is equal to 1. So b is equal to 2 and a is equal to 1 we have found, but show that f of minus 2 equal to 0. We have to show f of minus 2 is equal to 0. So what is our f of x? F of x is equal to ax plus b divided by x plus 1. Now we are having the values for a and b. So 1x, that is ax, plus 2, b is 2, divided by x plus 1, that is x plus 2 by x plus 1. That is our f of x. What we have to find? We have to find f of minus 2. F of minus 2 means in the place of x, you have to substitute, you have to apply, you have to put minus 2. That is minus 2, okay, f of minus 2 is equal to f of x is x plus 2 by x plus 1. So f of minus 2 is minus 2 plus 2 divided by minus 2 plus 1. Minus 2 plus 2 divided by minus 2 plus 1. Minus 2 plus 2 is 0. Minus 2 plus 1, that is minus 1. 0 divided by minus 1, and that is equal to 0. That implies f of minus 2 is equal to 0. That's the answer.